Hi friends, today I'm watching and reacting to this Better Software conference video which is called You Should Finish Your Software by Skill Steinberg. So let's see if we learn something.
It is my pleasure to introduce the next speaker. I cannot list every tool and library that he has worked on. Kel Solar here mentioned a pack of libraries. He is on the C Standard Committee and he has some spicy C opinions as well. So hopefully we'll hear it. So give it up. A round of applause for Eskil Steinberg Hall.
Is my mic on? Yeah, good. Everybody, I'm just an introduction for people who don't know me. Maybe in the community, I'm mostly known for a video called How I Program C, which is far too long. But over the years, for some reason, it's gotten 800,000 views, which is crazy. I wrote a long time ago, a real-time networking protocol for 3D graphics that could synchronize multiple applications sharing 3D data called Verse, which is a little bit like Omniverse, actually. I've written my own 3D modeling tool called LuckaRow, which is a subdivision surface modeler. I wrote a game called Love for a long time, which was a procedural first-person action-adventure game, network game, and it was scratch-written. I've written a fully automatic UV unwrapper called the Ministerial Flat, which is an algorithm that basically does UV unwrapping, but very, very much like a human would do it. This is also licensed in Cinema 4D. So if you have a license to Cinema 4D, you can play with it. If you don't, you can go to ministerialflat.com and download a copy. I've written the file format Haxa, which is a really simple asset format for loading polygons and pixels, basically, mostly for like people who are like us who want to program and don't want to have a complicated thing and just get some pixels into our little toy engine or real engine. I worked a lot with LED controls, so I've written several applications to do where you can design LED setups. And yes, I represent Sweden in the ISO VG14C standard. My main things that I'm interested there is undefined behavior. I'm authoring a paper that is going to describe for once and for all how UV works. I'm interested in the memory model and concurrency. And I'm also working on a hardware project called Eskil, which is going to be a luxury brand for some cool hardware that I can't really talk about yet. And last week, I launched a gaming studio in my apartment. And so that's really cool. 2 employees. We're going to have a lot of fun. And everything is going to be streamed. So you can find me most days on Kel Solar. And I stream pretty much all my development. So come and ask questions, come and hang out. So I want to talk about a problem I have. I have trouble finishing software. And I have trouble finishing a lot of things because I like starting things more than finishing things. Because it's hard to finish things. I think most people who've ever tried know that. But I want to talk about in a larger sense because I think we have a culture of not finishing things in software. And I would argue that good quality software is finished. And I want to talk about the word quality for a second, because when people in the software world talk about quality, they tend to use maintainable as like this thing we should have in software. And I don't think that makes very much sense in any other.
Let's see what he says, because for me quality is which is the matching between what people that are using your software or are buying your software or both. Software is behaving. If your software is behaving like the customer, quality is okay. If there is a mismatch, quality is not there. So let's see what he says.
Context, like if you went to a car dealership and they said like, oh, this is a super high quality car, and you'd be like, oh, great, so it's not going to break. Oh, no, it'll break every day, but it'll be super easy to fix. You wouldn't think that was like a high quality car, right? This is very weird. Why are we like this, right? Well, some people say, software can always be improved and, it's a continuous project and, imagine if this was like that for building a bridge, where we started building a bridge and it was like, when can we go over the bridge? And people were like, well, it's not the greatest bridge that could ever possibly be built, And it's like, oh, they built something in China that was really cool, so we need to restart everything. And it's like, can we get to the other side at some point? At some point, it's actually more valuable to have something that works and that is finished and completed than having something that is continuously being improved. And is it really being improved? Can I trust you to make it better? I mean, we have a lot of examples of
Well, the problem is, what is the definition of finished? Who is defining that in your software? Because the client might think that the software is never finished. There's a conversation with them about whether you are still going to work on that because you are still having the compensation that you need to do that work. Do you have a contract specification about how it should work? Which are the limits? Which are the use cases? I don't know. It's not so easy because, you think, okay, software should be finished.
Keep working at it a long, long time, and it's not getting better, right? I think we have this, expression now and shitifications that's like, if we just work on it enough, it turns into shit. And I think we people need a goal. I think that's an important part of.
Yeah, I agree. That's what I was talking about. You need an end goal. And that's the definition about finished software, I guess. Once you've reached the end goal, might be testing a product, or you might think that you are in the maintenance phase, which should have low development.
Of any project. If there's infinite time, why prioritize? We can do it in the future, right? Why fix this thing? We'll do it some other day. It's like there will always be a next release, Why should we?
Well, because the order is important. Even if you have infinite time, you don't have infinite time in a parallel sequence. Things are done. You have a lot of developers, perhaps it's like you have a lot of queues.
We commit to anything. Why should we say this is the thing we're doing when, we can change, We'll do a little bit of this and a little bit of that. Let's not make any decisions, right? Just ship it, right? We'll ship it. We can fix it in the next patch, Who cares, right? What if the software did something completely different? Maybe we should just change everything, And this keeps happening. This mentality breeds bad software. And it's not just people say, oh, it's management's fault, but I see this from a lot of software developers. They're like, I'll clean this code up when management gives me time. And it's like, no, finish your software. If you show some.
Then here we are talking about technical debt, perhaps about bad code in general, or should be able to talk to product and the stakeholders about how it was the impact and having a plan to tackle it. So what he's talking now is the typical thing that, okay, it seems like the product works, it's finished or is almost finished, but you know that the code has a lot of problems. Perhaps there's low code coverage, bad layering. And if you are not able to tell that and explain that to business, then it's like the problem doesn't exist, because who's going to fix it? Are you fixing it while you have a lot of things to do, prioritized by product or by business? Or if you think that you are like an infra team and you can be your own stakeholder, perhaps you can decide and put effort yourself. But if whatever you do is going to be prioritized by product, somehow you need to explain product the impact about the state of the software, and they should be able to understand it, because usually there is something that is going to impact the user or the business. The site is not behaving well, it's slow, we are not scaling horizontally, or we might have problems debugging and the operation is going to be a nightmare. There should be always something that you can explain to any human, be a reason to improve the code or to remove those kind of things. It should not, I think it should be something like, okay, I know it's wrong, and I'm going to be in my dark room and fixing it, and product and business are not going to know, but I'm going to be very proud that I've fixed it. That's also a problem, because then perhaps from the outside it seems like you are doing nothing, or you're not doing the most priority things, but you are actually cleaning and cleaning. There is no reason to clean if you cannot explain why you are doing it and the impact of it, I think. What do you think? You put a comment?
Something to a manager that looks done but is garbage underneath, they will look at that and say it's done, and they will do the next thing. They won't say, well, obviously everything looks perfect, but it's garbage underneath, and I'm going to give you a bunch of time to fix your thing. Like when you show something to a manager, if you're employed, that's the thing you're delivering.
The problem is that that's the conversation that should be happening during the project. Like, okay, we are advancing at good path, but we are creating this technical debt on purpose, of those kind of things. Or Sonar is crying, but if it's too late, business or product, they are not going to understand it.
Right? Either you have to have a manager that understands you, actually go through the code and look how terrible it is, you know. But if they can't see that, they're trusting you, right? It's like being burned.
I guess that if you have an engineering manager or a tech lead or that kind of role, it should be part of each responsibility to be aware of it and raise it. Do something about the prioritization of the tasks to make that important.
Bernie Madoff saying like, well, we lost out on, you know, profits this month, but let's not tell the investors because we'll make it up next month, right? You know, and we'll smooth it over, right? And then 10 years later, everything's like, why is this a house of cards, right? So it's not management fault. A lot of times it's our fault as well. And I know what you're thinking is like, oh.
Yeah, I agree. It's probably, I mean, it could be, as long as you've been telling them, not at the end. That's the important thing. Not like, okay, you have this deadline, go for it and finish the product. And then it's like everything in the UI or UX matches with Figma. But then when you're using it, there are a lot of problems. That's not finished. I mean, the definition of done or finished of the software is to be the full stack. At least if you have a QA team, it's like they have their own vision and they are going to challenge you, but sometimes you don't have that, and you need to be yourself the one who knows what is the expectation of the quality and being able to deliver that, and not only like, okay, this is like functional software.
We can't build like similar things. You know, we live in a complex world where things are changing and requirements change and yada, yada, yada. Having hundreds of people simultaneously redesign a system does not scale. We can't have everybody working on a huge thing at the same time, developing in every direction and think that it works. There's a reason big software project fails, right? All software should be possible to be written by one person.
This is like a big claim. All software, and you need to have the needed time, right?
And I used to say this as sort of, here's my thought experiment. What if we did it this way? And the more I think about it, it's not a thought experiment. I actually believe this. I actually believe that there is no software in the world that one person can't write, right? Because if it isn't true, imagine the world where it is true. Make it true, right? Break it down into its components, right? So can I get an example of like a really large software project that a person couldn't do? Can somebody think of some things too big for Chromium? Great, okay. So obviously you could say from one point of view, you could say, well, the application is very simple, right? So if you have a widget that draws HTML, you're good, right? Somebody should just be able to do that. Anybody can do that, right? Or you could break it down from another point of view, saying, well, all you're doing is curl, right? And then, you know, that's all you're doing, and then people can build on top of that. Or maybe somebody does a rendering engine. You know, you can make it into a bunch of components, and then it works, right? Any other examples of hard software?
I don't understand the explanation. I mean, yeah, Chrome is a huge project. Can you do that with one single person? And he said that, yeah, you can split this in several components and everything. Yeah, sure, but you have all those components, and it's just a matter of easy integration. But the Chrome software is not just that.
Yeah, well, people are making AAA games today alone. I mean, I've always made one myself, almost, but people are doing it in Unreal, right? People are making things that look AAA because they have, you know, engines that exist, right? So you can always break things down. And the way we should communicate with each other is over APIs.
Okay, so his point is that any software can be done by one person because you can split it and communicate with those components with an API. And I guess you can be just one person doing it because you are just integrating most of the parts with APIs, and you are just focusing on one part. I don't know, it's a bit twisted.
Because humans are very much like CPU cores. We are really productive and really good until we need to synchronize with another one. Then we become incredibly slow. So you really, really don't want to synchronize with others if you can avoid it. And APIs is the way we do that, right? I've met a lot of people that have trouble working with the person sitting next to them, working on the same project, but they're happily working against an API in, Linux that they've never met the people who've done the. It's just a document in API, and they use that, and they use someone else's code, and it just works, right? There's no questions. Everybody's like happy. But working with Bill sitting next to me, that's like a nightmare. We're fighting, and it's like trampling over all over our code.
Well, I guess that's because if you have an API from another team, there is not a lot of discuss. You check the API, you check the Open API specification. If it's okay for you, you can use it right away, and you just need the integration details. If there is no API, it's like there is like a open discussion to be done with them. Like, I need this, and they will challenge you like, why do you need this? Because this is difficult and everything. I don't know. Yeah, of course, it would be great if everybody would have an API for others, but usually you only build APIs for use cases that already exist, not for things that do not exist. So you don't have clients, you are not building APIs for everything unless you have like a clear understanding of a client you are going to have in the future.
And I have this expression about building a mountain, right? You want to build up new things so that you can build on top of them. And here's the example of how I think about this. Have we gone to the moon? Mankind has gone to the moon, right? We've been there. But can we go to the moon? Well, in theory, we could go to the moon, but if we were to go to the moon, we would pretty much start over from scratch. We don't have any Saturn V rockets lying around ready to be fired. We don't have a moon lander sitting in a, shed somewhere. We would have a couple of really old dudes we could ask questions from, and they would say, well, in our time, we use computers that, run 1 kilohertz or something, so it wouldn't be very useful. And this is really what's important, thinking about accomplishments versus capabilities. When you're writing software, are you gaining just an accomplishment of like, I made a game, I made a text editor or something like that? Or did you gain capabilities? If you make a text editor, you should gain the capability of doing text rendering really, really well, so that you can go off and do something else and you don't have to think about text anymore because you have conquered that. That is now a capability. Solve problems so that they remain solved. Like a great example is like if you've ever done network programming, you start with sockets and you have all these structs that have fields that are called things, and there's flags, and you're like, okay, I have to look this up. What is the thing? What flag does I have to set up? And you try to focus on only getting the thing you need for your project. Well, go through all of them. Make a wrapper around that so you never, ever have to look up that documentation ever again and say, okay, networking is solved. I have libraries for that. It does everything I want it, and now I'm done. This is how you can go much further. Because here's my best example of this, right? People say Apple made the iPhone. Well, Apple had made a whole bunch of things before that. They had made iTunes. They had made, they had a proper OS kernel. They had a desktop compositor. They had OpenGL. They had a Safari. They had a mail client, right? All of these things they built over the decade before the iPhone came out. And then one day they can say, okay, we can make the iPhone because we have all these features, right? And a company that hadn't built up these layers of capabilities wouldn't be able to build this product. And the other thing is you want to keep your context windows small because just like CPUs, we're bad at context switching, right? If you constantly have to jump between different problems, you'll be slow, right? You want to solve a problem so you don't ever have to think about it again. And your mind can really only let go of code once it's finished. And it's not just good enough. It doesn't just have to be good. It has to be so good that you don't want to revisit it. You know that, like, I went into that and I went so deep and did it so well that I'm never going to be able to do it better. And I actually have a problem with this. I don't have a not invented here problem because I've invented everything here. Like, I have a source, You know, I have my own UI toolkit, I have my own platform layers, I have everything, right? So I don't ever have this problem. What I have is not invented here recently. I have a like, yeah, but it's been 2 years. I'm a better programmer now. I can redesign this, right? And that's why you really, really have to push it and be like, no, it can't be done better. Or it's like, the gains are ridiculous, right? It doesn't matter, right? For this to work, you should make your software extendable. And there's multiple ways of doing that, right? You build your software on top of other people's, right? Other people's work. Even if you're writing your own operating system, you're building it on top of hardware other people built. But can people build on top of you? Can people reuse the code you're using? And can your software be combined? Like, can you pipe data into it in a Unix command? That's a very simple way you can have in and out and use your software in a chain, right? Or maybe, you know, you have your own API that people can call. Maybe you're a library. Maybe your software has a plugin interface, right? Don't impose your conventions on your users, right? So I see this a lot of like, you know, especially C++ programmers. They build big structures, and it's like it handles everything. It has a thing, and you have to have a handler and a thingy and a callback and a thing, and then you can plug everything into this. And you're like, no, don't do that. Like, make something that is easy to, you know, use, an API that you can use that doesn't tell the user that they have to live with your worldview, right? That's why I don't like things like memory allocators. Like, I don't care about your memory allocator. You can use your memory allocator inside of your library. Like, I don't want your vec3, because I don't want to move all my values into vec3s, right? I just want, it's okay with a function that takes 3 floats. It's fine. Don't force me to live in your world, right?
Or just use a JVM, right? I don't have those problems.
And build utilities for a lot of things. Let's say you make a format like a JSON format, right? How do you get other people to use it? Well, maybe the JSON format is super simple, but if you have all these tools that allow people to do it, maybe there's a Python interface, maybe there's, you know, a visualizer, maybe there's a UI for it, maybe there's a validator for it. Wow, then people want to use it, right? Make it easy for people to use it by building utilities. This is not always true, but I tend to think that you want to build software that other people can plug into their software rather than having their software plug into yours. Plugin interfaces can be great, but you always have to live in somebody else's world under their constraints. And generally, people don't want that, right? And the thing about this is that in order to stand on the shoulders of giants, giants have to stand still, right? You need your development to stop so that other people can start doing things. If you change your API every day, or like, oh, you know, this switch here now means something different because it's smarter, it's better. It's like, doesn't work, right? Collaboration works when we can depend on each other. This is really important. You have to build trust so that people trust that the software I get from this person really works. And how does software work? Software is built, trust is built over time, right? You won't trust my software until you've had it for a while, right? And therefore, I'm really arguing that people need to build dependable software. And I would argue that the worst disaster that has ever happened in software is probably this, right? And it's like, people were like, well, Python 3 is better. You know, a few engineers at Python said that. And then untold billions of dollars had to be paid by the world who were relying on Python 2 to upgrade because they were like, well, it's nicer when the prints have parentheses around them. Right? That is really what the world needs to spend billions of dollars on, right? And this is really terrible. And that's why I think stable ABI is the most underrated feature anything in computing. This should be our North Star, right? And there's a lot of, but this one is newer. Yeah, but this one worked. That's always more important, you know. You should always, like, if I've had a software run on my computer for 15 years and it hasn't crashed, and you give me a new version, which one do I trust, right? If you're going to get on a plane, and you have 2 options. One is the latest plane that came out of the factory, a new model, #1 on the factory floor. It has all all this most modern safety equipment, the most modern safety standards, everything is new about it. And then there's another plane that is, 20 years old. That model has been flying for 20 years, and it's never had a crash. Which plane do you trust? I know what you're thinking. You're thinking, which one is a Boeing? So
Airbus for the win.
change is a huge cost to your users, right? We've all been there, like, where the fuck did they move the button, right? And some UI designers like, well, it's much more nicer now, and the aesthetics, and it's like, we don't care. Like, we don't care about your software, we care about our work, and every time you update, you force me to update your software. I have to stop thinking about the things I'm working on and start thinking about you. It's like, you're not helping me now. You're stealing things from me, right? There's a great movie called Pirates of Silicon Valley. It's a TV movie about the birth of Microsoft and Apple. And I really, really like this movie. And there's a scene at the end of the movie where Steve Jobs realizes that Microsoft has stolen all their ideas pretty much and made Windows, a copy of the Mac. And he has this huge outburst, and they fight over this, and and then Bill Gates leaves, and as he leaves, Steve Jobs says, we're better than you. We're better, And Bill Gates turns around and says, you still don't get it. That doesn't matter. And I think about that scene a lot because, as creator, we think, well, better is better. It's got to win, right? But a lot of times that's actually not true. Because people care about other things. And this movie is really hard to find. So if you ask me afterwards, I do not have a pirated copy on a.
I've watched it. Not a really great movie. Terrible acting. I remember that movie. It's fun to watch.
Let's be dry. So the stable APIs are not cool, right? It's really fun to make fun out of all the old crappy, Windows APIs. They look terrible, and we can laugh at them as a bad software design. I can't believe they still have this. But you can run software from the 90s on your latest machine, and it will just work. This is the reason why Linux has never broken through. Linux, the kernel has a stable API. Linus Torvalds, awesome guy, he gets this. But all of the distributions, they're like, but this is a newer one, right? So if you release a piece of software, a binary for Linux, it's not like, here's my Linux release. It's like, here's the Ubuntu release for this version of Ubuntu. And if you have anything else, you're screwed. I'm expecting that if any of the Linux distributions ever put their foot down and say, we're not going to ever break ABI and we'll not accept any software that breaks ABI, that Linux distribution will just win. People will say they are old and people will say, we don't like you, but they will win. That's my pretty...
Yeah, that's a good conclusion, but the thing is that in Linux you have so many different options for the high-level layers. GTK, Qt, and there are a lot of moving pieces with different alternative software. And then the C library might have a major change, and you might have, a different system to manage the processes. And whether you have SE Linux or not, there are a lot of things that at the end of the day, I think that if you are really into it, or you use Ubuntu or similar, that is the major one, or you just compile the software yourself.
Pretty hard guess. So, and I believe in a stable ABI also among friends, right? We can talk about Microsoft being a big platform. So I have 2 employees. I pay them. I am the boss. I own the company, but I cannot break ABIs for them. I wrote an engine, and they're writing games in that engine. If I made a fucked up API call and I realize I need to do it, I have to write a new API call, and then I can tell them, when you have time, start using this one instead. I can't tell them, you have to drop everything because I'm going to break your code, right? I have to be, for them to use my code, they have to trust me. I have to, and that might mean I have to write a wrapper. I might have to, if my code becomes uglier because I do that, that's my problem.
Yeah, I think this is not something weird, right? In my teams, I remember if somebody is breaking libraries or something, or utils or classes, and they need to push a change that is not backward compatible, and it means that people might have to refactor their active work. you need to tell it, or you need to avoid that breaking change.
Stuff, my ugly code is my problem, not my user's problem, even if they're sitting next to me, even if I'm the one paying them. So dependable software requires a different mindset. We have to think differently about how we write software. So the obvious one is only use dependable APIs, right? We want to use APIs that we trust, and we want ideally not to have dependencies. If you have dependencies you control. Are they compiled in, are they part of the source code, or are they, the operating system you can trust? Don't tie yourself to any platform. Lots of people do that. Like people today build software that relies on a web service being online, that's not very good. And when you rely on things, wrap those APIs, because you don't know. Microsoft may blow up and you may want to go somewhere else, right? So you want to have everything be portable. So even if you require some platform-specific things, you want to be able to move away from that at any time. Language-wise, I want to use something I call dependable C. So I'm in the C standard board. I make language, or I'm supposed to at least. And I had this sort of idea, which was that I use C89, and I've used C89 forever. And obviously, we can all have arguments over, what a language should be. Let's imagine that the VG14 was like, oh, Eskil, you're so bright and so special. We're going to defer all decisions to you, and we're going to write the standard exactly the way you want it. You can make all the changes you want, and you'll have the perfect language, right? And I'm a pretty hardcore advocate for old school C, but I in no way mean that old school C is perfect. It isn't, So I thought about that, and it's like, okay, let's see, this magical Uber Eskil C now exists, and let's say that the major compilers were like, oh, well, of course we're going to implement that. Would I use this? And I realized, no, I wouldn't. Even if I got everything I wanted, even if it had my name on it, I wouldn't use it. I want my code to run on anything. I want my code to be readable by anybody. I don't want you to have the latest version of anything. Being connected to the world is much, much more important than whatever feature I could get out of it. There's nothing in C that I can't fix with 5 lines of code. So I think of languages as a storage container for instructions, right? We're putting down our time into something, and that is what the value is. It's like if you do work, you want to store that in money that is going to last, right? And C is really, really the gold standard. I can guarantee you that if you write in C89, your code will be compilable in 50 years. There will be a compiler for the supercomputers we have back in the future. It will work, right? And that's more important than anything, right? Because really, value is you make something that does something over time, right? If it breaks after 2 years, then it's half as valuable than if it breaks at 4 years. And with C, you can make it last for 50, 100 years, right? And even C is so simple that it's the first thing you implement on any new platform, right? You can even, if shit hits the fan, you can write your own C compiler for your own home-built hardware, and your code will run there, right? That is not true for almost any other language. I don't think of a language as a tool. A lot of people talk about language features. I don't want the language to solve my problem. I like debuggers. I love, tools around it that operate on my language. The simpler my language is, the better my tools are, right? Because the easier it is to build a tool, right? Everybody knows that it's like a simple file format everybody can make use of. If I make a complicated thing, all the tools will suck, right? So I love this. This is a little bit old, but these are all the operating systems that Curl runs on. And it's actually over 100 now, because I couldn't find the latest slides, so Daniel Steenberg is the credit for this slide. But you can't do this in anything other than C89. You can't do this in C99. And sure, you can get a lot of it in C99. But if you really, really care about being understood by everybody, this is where you should go. And this is kind of interesting. If you ask people I want to write this piece of software, how should I do it? Generally, people say, oh, you should use React, or you should use, this new language, or this with this system and these frameworks, and, they pile on these, oh, I just read about this new technology that will do this, right? But then you ask them, it's like, I have solved this problem. What do you wish it was written in? And it's like, everybody's like, oh, please don't come with a bunch of, a huge C++ thing or, some weird Haskell. Come with a small C library in C89 with nothing in, no dependencies. That's what you want to integrate, right? When I made the UVN wrapper, I went to Maxon, and Maxon's, all their software is C++, and I said, well, I'm sorry, my software is not C++, it's actually only C. And they were like, oh, thank God, because we like being in C++ for ourselves, but we don't trust other people to write C++. God knows what they...
Yeah, I'm not so C++ guy to laugh at these jokes.
C++ interfaces, you can't trust that, C, that's fine, right? So think about that, like, you don't, if you have a lot of sort of syntax sugar, that might be nice for writing it. But for using it, it's like, I don't want syntax sugar, I want performance. Syntax doesn't solve your problem. And I kind of think that convenience is very overrated, right? I think that the convenience you get from a lot of higher level languages really just, hides things, and it makes it quick to get off the ground, but in the end, you're going to want to control that. In the end, you're going to want the software to be super, super fast. Typing is easy, right? Typing is not the problem of programming. I'm the worst typer. You can check me out on stream and laugh at me if you think typing is important.
Yeah, I agree with that. Actually, people are talking a lot of LLMs and about productivity. Just typing the code is more about thinking, about analyzing, about talking with people, about knowing the requirements. It's everything that happens sometimes before you are doing the code and at the same time, but not really the code itself. The scaffolding, probably the LLMs can break a lot of that, but sometimes now that people are talking about artificial intelligence, sometimes the amount of code, out of the cost of the code in the projects is being...
Code is meant to run, and I think one thing that struck me was I was reading an FAQ on the Linux kernel, and this is like, why does the Linux kernel have a bunch of go-tos? Isn't that really ugly? And the answer was like, it generates better assembly code. The Linux kernel is an engineering project meant to run. It is not meant to, you're not meant to read the source code. You're mean to actually use it, When you create a piece of software, here's my model for how I create software projects and how I try to finish them. So I start out with a plan. Usually I have a couple of software projects in my head that I haven't started on and maybe even not decided whether or not I want to do, right? But I'm thinking about, what the structure is going to be and I let that fester for a while. Then I write sort of 80% of the code. Right? Because I know what I want to do. Here's, the majority of the thing. And then usually I make parts of that as libraries. So that like, oh, this thing I need, a lot of times this is part of sort of the project. It's like, I'm going to write an editor for text, but I don't have good spelling thing. Okay, let's build a spelling library. I can use a spelling library for a lot of other things. Let's build a spelling library, So you sort of have these sub-projects that you finish, and actually you could sort of look at this recursively because the structure of the project that I'm showing, you could actually shrink that down and put those in the green and the blue box because I would kind of do the same thing. Then after that, I do a lot of revisions because once you get to like 80%, then you can start using the software. And then you realize it's like some of your ideas weren't perfect and some things are a little bit fidgety and, so you have to make another sort of thing. And you can do that. You don't have to finish the application to do that. You can just tell that like some of my assumptions weren't that great, so I need to do some revisions, right? And then you get to sort of 1.0, right? And then after that, you do a bunch of revisions where it's like, oh, I need more features, I need this and that. And then you can see they start spacing out. It's like, and if you think of this as a library, it might be like, the beginning you're like, oh, I need these features. And then eventually, very seldom do you like, oh, I'd like another version of this function that does this slightly differently. And then I'm done. Except now I start planning. If I want to do a second version of this application, let's say I want to do 2.0, and a lot of projects I just wipe the project and start over. And an example of that is the lighting software that I've written. This is Stellar 1.0, and here's Stellar 2.0. And those two applications share none of the source code. It's a complete wipe. I have all the knowledge. I knew all the things that I did wrong in 1.0, and we're able to refactor and restructure everything, you know. Each one of these took about 9 months to write. So, but then the cool thing is the blue and the green box, I can reuse them, right? So I'm not actually starting from scratch, right? I can actually, you know, have a completely new design with a completely new paradigm, but I don't have to reinvent my font rendering, right? That doesn't matter. Right now, I'm working on a game engine, and this is kind of what it looks like right now. So the game engine actually, the majority of the game engine was written in about a week and a half. But then I've written a geometry library that does like collision detection, it does full destructibility, pathfinding, and a lot of things like that. And now I've been working on my serialization library. And as you might see on the sides, I've sort of went overboard a little bit. So the serialization is a lot more than you need for my game engine. But it's going to be awesome, I think, if I can finish it. And this sort of permeates a lot of software. So I want to introduce you to my favorite games of the last couple of years. This is Battle Aces. It's a strategy game. It's awesome, except you can't play it because the economics of finishing software is terrible. Originally, we had this idea that we would, the amazing thing about software, you could develop a software product and then you can sell it an infinite time. Isn't that magic, right?
Oh, it's magic, and I think it's part of the reason why we have good salaries even in Spain. Like most of the people, there are really people that do great things and really complex things, but if you only have one human client, you can only be paid by one human. But as long as the software, you usually have like a huge impact when you're with your software. So it's usually, it became clear that it's easier to have money for your projects when you are so much impact. It's easier to have impact with software. Perhaps you can, I mean, if I'm just working on rebuilding houses, like repairing, really easy, but I need to do it one by one. I cannot build like, it's not easy. Perhaps like a building block, but you need to scale. I think it's the matter of that in software you can scale the job, the work you've done to a lot of people. Your company knows if you work for a company, so they can reach a lot of clients, because it's really weird making software just for one. Perhaps like a little company, little consultancy companies do that. Companies try to do that.
It wasn't like, you know, building a car and when you sold it, you had to build a new car to sell. That's expensive, right? And software was amazing because you could develop it once and then just like sell and sell and sell. And you get things like StarCraft, right? StarCraft was released in and there's still professional tournaments being played. The game is still selling. And shouldn't this be the goal of all of us, right? Just create something and then have it live for 30 years and just like being resold and loved. You know, that's what we want, right? The problem is that people looked at this and was like, oh, this is nice, but infinite repeat sales, that'd be nicer, right? What if we make it subscription? Or what if we... And the problem with this is that once you get into this, you also get into this, repeat development. We have to justify that you pay us every month by new features, by changing things. And the problem here is that the game I showed you, Battle Aces, was built under this model. And they basically run it in a beta, and they realized, even though the game was perfectly finished, that these two numbers weren't going to correlate correctly, so it's canceled and dead. So instead of getting a game we could all play, we now have a game that most of us will never get to play, that was buried because, you know, they had the idea we're going to make a game that we never finish, and therefore we have an infinite cost of development, and therefore we need to have a lot of money coming in the door.
This is typical in App Store and Play Store. Like, there's people making software like an application. It just does a little thing, but you need to have income with that software. You don't want to sell that once. So it's like when you start having different versions and you see that you've bought version 6 and the developer deprecates that. So you had a lifetime license, but it wasn't a lifetime license for that version because the next version requires a new payment. At the end of the day, like, it's finished software, but sometimes you need to do new features, even they are not needed. Perhaps the client do not have them, to have the excuse of having a new version. I've seen that in a lot of mobile applications, for instance, new video games and everything. Like you always need to push. That's why I think they most prefer the subscription thing, that you pay monthly and you're not thinking about having purchased a version forever or an application forever. Weird. You are subscribed to have for €1 and they prefer you to pay €1 a month than paying €50 forever.
This really sucks.
Yeah, that's.
So therefore, I'm asking you to ask yourselves this question. When you release software, would you be fine with it being your last, at least if you've gotten to 1.0? Like, is this a thing that is just a bunch of holes where you're hoping to fix it later? Or is this something you're like, if I get hit by a bus today, people will be...
Well, that's a good question, like a good question mark you have when you are...
proud of my software, you know, decades into the future. So I didn't really have a good ending, so I'm ending here. Here's my contacts, so you can find me on Twitter and Blue Sky, and that's the website for my company. And yeah, come and follow me on Twitch. Thank you very much.
I think now we have
Då var vi här då.
questions.
Då var vi här.
Ja, härligt.
Ja.
Så
Skönt.
maybe we should switch over to English, but we could do this in Swedish, right?
No, please no.
Wow, I too have a lot of unfinished projects.
Yeah.
I have a lot of them, and it was amazing listening to your talk because I was like, wow, there's this like this is why do you think why doesn't people do this? Because it makes so much sense. How did we get so far from what makes sense?
I don't know. Yeah, it's weird that I kind of have to give this talk. It's something I found a lot with my own development, that it's like, right now I'm working on Marshall, which is my library for storing data and serializing data. And it's like serializing data is kind of easy, right? It does, you know, and therefore it's really easy not to use a library because you can just write a few lines of code. Why should I bring in this massive project to do that? Well, it has to be so goddamn good that I get so much out of it that I will actually use it. And it has to be so trustworthy because I can't debug it, you know, when I'm using it. It has to be so rock solid that I trust it. And right now I feel like it's not good enough. I'm never going to reuse this. And I know I have to push it over the edge of being, I'm trusting this software and I will use it forever. Because there's libraries I've written that I use for everything, and there's libraries that I've used once and never used again.
I really like this because one thing I like this not invented recently mentality. That was like, oh yeah, I go back to this piece of code and I'm like, I need to fix this. This is not recent enough, or this has become out of sync with what I know. But if you build it that great that you kind of can put it behind you and you can like, yes, this is actually done. I can actually depend on this because it's stable and I know what it does and I understand it. And then I can continue.
And also it's like sometimes if it's like a little bit over-engineered, you're like, I went to such great lengths with this. So like things I do is like, okay, you know, you have a key value store, you have to compare a string to, you know. So the thing I do, for instance, is I guarantee that all strings are at least 4 bytes long. And that means I can do the beginning of the compare with the 32-bit compare instead of doing individual bytes. And it's like, that's a little bit too much. I wouldn't do that normally, but it's one of those things that's like, yeah, I should use this code. This code has really been optimized and, you know.
You said that you don't think about languages as tools, and there's so many different, like we have a lot of languages showing up and people are trying to solve problems, but your approach is more, well, we're going to use this to build something, and really we don't need much. Like you have, like I appreciate some of the C99 features, but you draw the line before that. Yeah,
so I do, for a couple of reasons. First of all, I really don't need anything in C99. C99 adds VLAs, which I think are really broken because they're basically a way to allocate memory that can't report that it's out of memory. And it allocates this from a stack, which is between 1 meg and 8 meg, depending on your operating system. And that's not very much memory. So it's a really, really dangerous thing. So I think that's one reason, but it's also other reasons, like I think C89 is slightly more ordered, and I also think that I want my code to be readable by like C++ people or people who are not like C99 is like for C programmers, whereas C89 is for everybody. I'm actually trying to put together a website, dependablec.org, where I document like what's dependable. Like if you want to write code that lasts forever, you shouldn't use a bunch of features, but then there's a bunch of features in C89 that are not really trustworthy for various reasons, or like, the things that are technically legal, but there's a lot of bugs in compilers around. So there's a little bit of sort of a fuzziness around it. There are things that have been deprecated. So, you want your code to run even if you don't explicitly say this is the version that I require, right? You want to just like default setting, run the code, and it works.
You would know because you are writing the book on UB.
That's a really exciting area. So yeah.
So maybe we should open up some questions from the audience.
So you're on the C standard committee, but you stick to C89. I assume you haven't been on the committee in 89, so you have never actually used anything you've done in the committee?
That's correct. I don't intend to. That's kind of the thing is like, for me, C is valuable, or the most valuable thing about C is that it's everywhere. Everybody understands it. It's stable, and that's more important, right? So I'm in the C standard board to protect that, right? It's like, and everybody has opinions about what's wrong about C, but it's like, to me, that doesn't matter. What matters is that it works, right? The problem with the C standard board is that they're all really smart and all really well-meaning. I don't really have bad things to say. The problem is, why do you join a language design group? Because you're a language designer and you want to design languages. And that means that everybody wants to add something, right? If you have 40 people in a room, everybody agrees that C should be small, except for the feature I want to add, and you have 40 people, and then, you get a bunch of crust, right? I think fundamentally,
mostly a Java gate out of the scope of.
there are problems in C, but you don't need language to solve that. And since C is backwards compatible, it sort of becomes a little bit of a weird issue where like, okay, you should use secure memset instead of memset sometimes, right? Only the people who know why memset isn't secure know to use secure memset, and the people who know that memset isn't secure know how to get around it. So you're sort of adding a feature to fix a thing, and to explain why the feature exists, you have to know the problem, and if you know the problem, then you don't need the fix. And it's sort of, if you could remove memset and make it safe, then be different, but that's not how the world, C works. So that's why I actually don't vote on C2Y, which is the next version of C, because I would just vote no to everything and everybody would just hate me. And I don't think I have, I don't go in and vote on C++. Let them build whatever they want. I'm pretty hardcore on C, and I want to protect C, and I think that's important that we do that. But if people want to go build Rust or whatever, everybody should program whatever they want. I'm advocating for what I think is good, and I think people should consider it. But if you don't agree, that's cool, right? You not agreeing with me is like, that's how I learn. So.
You got it, and you have it.
Yeah,
Right.
I got the language or a good enough language. It's like, I don't care, right? It's like, yeah, there's stupid stuff, but typing is not the problem, right?
There. One of the things I wanted to poke at a little bit is you had mentioned that code is meant to run, and so things might be obtuse for a reader, but they might actually be the best thing for the program, right? One of the nicest things about C that I find is that it's kind of a common ancestor of many languages, and so it's sort of the thing that most people are able to understand, the kind of common language for code. And so I particularly like that if I'm writing a piece of code, even if somebody doesn't use that code, they might come across it, read it, and know where it would apply to their thing, and take the pieces they want, make their own version, that sort of thing. What is your opinion on that sort of sharing, where it's it's not actually, in that sense, it's not done, right? They didn't use my thing off the shelf, they went and made their own thing, but the concept is...
Yeah. Yeah, and I think I do that myself, you know. I don't copy code from anybody, but I hear ideas from people and then I make my own thing out of it. So I think that's great. But that's one of the reasons like I don't like macros. I use very little macros because I don't like looking at code and it's like, oh, here's a thing, and it's like the dude who wrote it thinks he's clever, but I don't understand it, you know. I'm much more in favor of if you want meta programming, just write a C program that generates C. You can debug both of them independently. You can read the output. Everything is clear. Everybody knows what's going on. I tend to want to ship the generated code and have the generated code be disabled because I don't want to impose like, here's the build step you have to do in order to get my code to run.
I think the last project I did, which was C++, it was pure C, I think. It was an Evolution client plugin, and it used was GTK, and it had a lot of macros that you need to consider to do everything. It's like they have a high-level object-oriented language over C. It's like doing object-oriented programming with C. So they had like macros for everything, and then you feel like you are creating objects and everything and managing the memory.
It's like the fact that I use generating to build part of code, that's none of your problem if you just want to integrate my code. But yeah.
Check in the generated files.
Yes.
Yeah.
Well, I don't check in because I don't use version control.
Okay. Do you do backups?
Sometimes. It happens.
I have done this too. Yeah, Rafael. Or there's anyone else? No? Okay, Rafael gets it.
That needs a follow-up question. Why don't you use version control?
It's never given me anything. Like I have, so the structure I use is I have a directory called merge source, which is the merge of all my source. And then I name all of my projects so that the beginning of the name is the name of the project. And sometimes it's like a hierarchy. So if I have like subsystems, they're named. So you can look at the file and just see where things live. I use the same names for the functions within them. So if you see a function, the beginning of that function is the file name where you will find it. It's all in one directory. I use, I develop on Windows mostly because of Visual Studio and the stable ABI. And what I do is that I have that directory in the same thing. I create a project. I go and select the libraries I have so that when I run a project, I always have all the files in there. I don't pre-compile libraries because I want to be able to do that. But that means also that I can have two different projects working at the same time using the same source libraries. And if I changed it in one, it will change it in the other. I can also do a search through this so that if I rarely do this, but if I need to change something, like in a library, I can actually search the whole source code and see where's that used, and I'll see all of my projects where it's used. So, and that's really all I do. I have a directory where I tend to put deprecated stuff. I tend not to delete files. What I do is I put an if-def deprecated around it, so the source is still there. And the reason for that is if you have a directory with your files in two different computers and you copy them forward, and then you delete one and then you copy and it's still there and it comes back and you get these zombie files. So instead I just keep it and just like if-def it out.
I mean, deprecating is one thing, but if you really need to delete it, I've actually found the project I was talking about, which was...
Another follow-up. So could it be described more succinctly as you have a mono repo with your entire life's work, but no history?
So every once in a while, I can do a sip of that and put a date on it. So I have some, I could go back, but I honestly can't remember when I ever...
I'm not sure I'm understanding this because it sounds pretty crazy.
Just a quick note, his mono repo is available online.
Okay.
Oh, wow.
You can go and check out all of his code.
You can also watch Eskil manage all this live.
Yeah.
Every day between...
Usually like 10 in the morning till just before 4.
Yeah. Swedish time, I guess.
Swedish time.
Yeah.
Yeah, longer on Tuesdays.
Also follow up. So, and junior programmers who work for you now, like those guys, they also put their files to your repo, or they do their own repo. Like how do you manage that?
So basically what we do, and so with the lighting, I was CTO of the lighting company. So I've been working alone most of my life. So I haven't had to deal with, it's a little bit weird to be in this conference, to be honest, because it feels like being in an AA meeting for like object-oriented survivors. And there's like, oh, I made it out, and I was like, I was never in, right? It's like, I never gave a shit about that. I'm just like born C, still C, always C. So it's like, but so a lot of people have said like, well, you're alone, this is never going to work. The way I've worked in the past when we've had team is basically we make our own, everybody makes their own projects. So either a different application or different libraries. And you work on your own machine, you have your own version, and then you make a release just like you would release software into the world. Just like you would, upload a new game, you basically say, okay, this library is now done to this level. I am now giving it to my users, which is the other people. The other people in the team are then free to ignore that because they might be busy doing something else, right? It's just like something that is available if you want it, right? And a lot of times people are waiting for things. They want things, but not always, right? And therefore, internally in a studio, we work as if we are, independent software companies that release software, and people update when they want to update.
So I guess he never has conflicts.
Yeah, you noted that a stable ABI is the most underrated thing in computing. What are some of your favorite stable ABIs, and what would you recommend we use more?
So 1.5 out. So it's like Win32 is the stable ABI. I mean, it just is, right? And I mean, Windows has like special code in Windows 95 to make SimCity run, because SimCity on Windows 3.11 did something weird. And Microsoft was like, what the fuck are these guys doing? Well, that's our problems, because it worked before, it has to work now. So they wrote special code in Windows in order to be able to have SimCity run, right? That is what a really, really trustworthy platform holder does that I know of. There's like the Linux kernel, so you can build a stable API system from a Linux kernel. Nobody's done that. Apple is terrible. They break things all the time. They just like, but this one's new, They're like, they're worse than that. They're like, oh, you should change your programming language. Rewrite everything in this new language now. That's like their approach. I think curl has a stable ABI. Those are, I would say, who else? You could argue that the web is a stable ABI, right? People write really shitty HTML code, and the browsers do their best to make that work, right? The browsers have so far never said, oh, these web servers are too old, we're just going to show a black screen, right? That has not happened. And the web was never planned for that, which is one of the reasons it's such a mess. But you still got to give them some credit for upholding that.
Yeah, okay, cool. Just on the ABI issue on Linux, I am under the impression that the C ABI is the ABI for the Linux, but that's not true.
So you have the kernel, which is the kernel, and that has a stable ABI, and you can search for like Linus Torvald rant stable ABI, and he will, scream at people. It's like, there's only one rule of kernel development. You do not break user space, right? So those are really fun. Yeah. But then there's the glibc, or the various C-libs that implement malloc and all of that. And those are not stable. People change them all the time, and those break. So even if you write like the simplest C program that doesn't, do anything except malloc-free and printf, you can still have your code be broken. So
let's see. Yeah, Andrew.
So if I understand correctly, when you're dividing work between yourself and your employees, it sounds like you're setting quite a hard boundary up front, and everyone is basically building their own library or building their own application and then connecting those together. Do you find it difficult to decide where those boundaries should be up front, or have you ever had to change where those boundaries are at a later time?
Not really. Think of it as like delivering an API to somebody, right? And right now, we're starting out. So I see my employees as my customers, right? I've built them an engine with an API, and they're supposed to be able to make a game in it. And anytime they have trouble doing that, I'm looking at myself, say, can I make it easier for them? Have I messed up? Should I change this? Should I, and that's kind of how I look at it.
In that kind of context, do you find that you change your mind about what should be in the engine versus what should be in the game? Which things are in which side of that boundary?
I could. I think the engine right now is pretty light. I'm expecting us to maybe build a project in the future that is like a standard library of features that is not in the engine, but that for developing stuff in the engine, possibly. But I can also imagine, different developers in the team making their own mini standard libraries with like, here's the things I keep using and I want to use, and they may not share those with other people, or other people may not want to use them. So,
Sander, did you have a question?
Yes. I was wondering about the point of Windows being a stable API, and that being a positive point, versus Mac OS breaking stuff all the time, which is obnoxious. But today we experienced once again Windows crashing and Mac being magically stable for some reason.
Yeah.
Do you think those are related or not?
I think they're related to the fact that one of the companies have to care about their own hardware and the other have to care about the whole world's hardware. It's like, Microsoft gets a lot of crap for things, and sometimes deservedly, but they're solving a very, very difficult problem. And they've gone through some like with Windows Vista, for instance, was a time when essentially the driver model was bad, so that DirectX 9 call you would switch into kernel mode, and that switch was so slow that you couldn't really get more than 50, because you would just eat all the CPU from the switching between kernel mode and application mode. And they fixed that with DirectX 10 by changing the whole driver model. And that meant that everybody had to rewrite their drivers for Windows Vista. And that's why Windows Vista was a disaster. It was blue screening all the time, but that's because every driver for the computer was brand new, right? And then they basically re-released Vista as Windows 7 and removed some pop-up, and people were like, oh, it's so much better. Well, it was mostly just the maturing of drivers. So, it's easier being Apple, but like Apple locks you into like, Apple is great if you do everything precisely the way that some Apple engineer imagined you would do it. And if you have your own ideas, don't think different. Whoever said that,
So the thesis of your talk is that you want to finish software, right? And at the beginning, I think you had mentioned that you feel like you have a software finishing problem, right? But by the end of it, I feel like that's not true. You have finished many libraries that you now consider finished, right? And so I think the nuance there, right, is that you push yourself to finish the library, but maybe that is actually counter to finishing the entire project as a thing to ship, right? So the game might suffer for the finishing of the piece that you want to rent, right?
I would say I probably have at least twice as many libraries unfinished as I haven't finished. So you may look at my public merge source is big, but my private is really big. So there's a lot of abandoned projects or things that, I didn't finish. So yeah.
Do you think that there are times where you would encourage somebody not to make a finished version of some particular library that is possible, because the rabbit hole in order to do that, right, that surface area, like the serialization library, for example, is that counter to finishing other things you could do, right?
Yeah, of course. You always have to think about what you're doing with your time. I think the problem I have right now with serialization is that I'm 90% there, right? And I need to put in the really hard, annoying last, they say in game development that the first 90% is easy, it's the second 90% that is hard. And I have the hard part done. And the thing I know is that unless I get over that and get to the other side, the 90% is wasted. It's just flushed down. It has no value whatsoever. And that's what's pushing me right now to get through it. But yes, I have other things to do.
Do you like throw away a lot of code before you like use it seriously in other projects or like publish it, or do you keep most of it for you?
I keep all of my code, so I don't ever really throw away code.
There's no like cutting. It's not like a movie and you cut out scenes. It's like you just keep everything.
I do usually I sort of do the whole 80%, and then when I do the rest of the 80%, like I change things. So, I think the serialization is really in on its like third rewrite or something like that. But there's parts of it that I mean completely rewritten, but it's like you write something and you realize like, I should have designed this differently. You move back a bit and then you go again. And then, so you iterate forward a little bit. But then when I reach the end, if I reach the end, then it's pretty stable.
Version 1 will just stay forever even if it's not perfect.
Pretty much. I can give you an example. I have a network library called Testify. And Testify has been with me for a long time. And I recently wrote Testify 2, which is, because it was like limitations. But Testify 2 is not dependable yet. And I still keep around Testify 1 because all these software that I've written uses Testify 1, and there's nothing wrong with that. Maybe I want to update them in the future, but that's not guaranteed. And Testify 2 is not really, So yeah, I may actually end up in a situation where Testify 2 never takes off and becomes this failed project.
So this is like in large part for yourself, not just for like other people. It goes both ways.
I think it's the same thing, right? Because it's like, if I finish a library and I know it works, then other people can use it and know that this is a working thing. But it's the same thing for me. I can work on something else and not have to think about that piece of tech because it's solved, right? It's the same compartmentalization of just having something you can trust. And whether that is software you've written or someone else, or you're writing for yourself or someone else, it's the same problem, really.
Okay, Sam, you had a question. Yeah, we are out of time. Okay, then, ladies and gentlemen.
Okay, you learned something from it. Has been interesting, really, really long. Interesting points, things to think about. I don't fully agree with the way he says that you need to share code or share things with your team. I think it's not the same. You cannot. I don't know. Perhaps because he has been working alone a lot of time, but I work with my mates in the same repo, and we share the work, and we take care that we know when a function is being deprecated and when it can be removed from real without needing to do an API against your mate. So I don't know. But interesting points of view, and same problem is that in any other language. It's C, but it's not like in C you can do a main.c and scale. You need to do also your layering and everything. There is an interesting talk that we might see in the future where he is hands-on explaining what is he talking about here. Perhaps it's the next video or now. And not much more. I